In multivariable calculus, we often need to calculate the volume under a surface where the base isn't a simple rectangle. Today, we will learn how to handle these using vertically simple regions, a fundamental technique for integration. Our goal is to find the volume of the solid bounded above by the surface and below by a region D in the xy plane. Understanding the geometry of region D is the first step to setting up our integral. A region is called vertically simple, or type 1, if it lies between two constant vertical lines and is bounded by two continuous functions of x. This structure dictates the order of our integration. In a type 1 region, the y values are bounded by functions. For any fixed value of x between a and b, y varies from the lower curve, g1 of x, to the upper curve, g2 of x. Think of the inner integral as finding the area of a cross-sectional slice at a fixed x. By integrating these slices from x equals a to x equals b, we accumulate the total volume of the solid. The order is crucial. For vertically simple regions, we always integrate with respect to y first. This allows the variable x to remain in the expression until the final step of the outer integration. Let's work through an example. We want to integrate the function f xy equals x plus y over the region bounded by the parabola y equals x squared and the line y equals x. First, we find the intersection points to determine our x limits, which are 0 and 1. Looking vertically, the lower boundary is the parabola x squared, and the upper boundary is the line x. Now we set up the iterated integral. The outer integral goes from 0 to 1 for dx, and the inner integral goes from x squared to x for dy. We are now ready to compute. We integrate the function x plus y with respect to y. This gives us xy plus 1/2 y squared. We then evaluate this expression at our upper limit x and lower limit x squared. Substituting the limits, we subtract the lower evaluation from the upper. After simplifying, we are left with a single variable function of x. This represents the area of a cross-section at any point x. Finally, we perform the outer integration with respect to x from 0 to 1. Applying the power rule to each term, we find the antiderivative that will give us our final numerical volume. Plugging in the limits 1 and 0, we calculate the final value. The volume under the surface over this specific vertically simple region is exactly 0.15 cubic units. To summarize, always start with a sketch. Identify your vertical boundaries as functions and your horizontal boundaries as constants. Integrate from the inside out, and ensure your final answer is a scalar. Let's test your knowledge. For a region bounded by y equals 0 and y equals sine of x, between x equals 0 and pi, the upper limit for the inner integral is sine of x. Mastering vertically simple regions allows you to solve a wide variety of engineering and physics problems involving non-uniform areas. Keep practicing these setups to build your intuition. Generated by Vision Solve AI.